I wanted to talk about graphs. They're possibly the most important mathematical structure in computer science. I'm sure you've encountered them before, you just might not know the terminology. But a graph consists of nodes or vertices and then between some of these nodes you'll have what are called edges. So if this is node U and this is node V, I've just drawn an edge between node U and node V. If this is node Y, then here I'm going to draw an edge between node Y and node U. So we have nodes or vertices, and then we have edges. And every graph that we'll be encountering will have some finite but non-zero number of nodes or vertices, and the graph will have 0 or more edges. So for example, here's a graph. It's just one vertex. It's a pretty uninteresting graph, but it is a graph. It's one vertex. This is the singular of vertices. Here's another graph. This graph has two vertices and one edge. So every edge connects exactly two vertices. So for example, you can't have a graph that has one node and one edge coming out of it. These are graphs that we'll never examine during class. We'll also never look at graphs that have one vertex and have an edge that loops back into that vertex. We'll never look at graphs like this. This is not a graph. We'll never look at graphs like this. And we'll also never look at graphs where there are multiple edges between vertices. So, you could imagine you have two vertices and maybe three edges between the two vertices. Nope, we won't be looking at that either. Our graphs will always have some finite but positive number of vertices, one or more, and each edge will connect exactly two vertices, and two vertices will never have more than one edge between them. We'll never have self-loops. So these are the absolute basics of what is a graph. So let me give you an example of some graphs that I'm sure you're familiar with. One would be a social networking graph. So imagine we have a vertex for every friend. Imagine this is Facebook. Imagine Facebook only had 5 users. Elin, Alex, Craig, Kurt, and Parth. And we'll put an edge between any two people on this Facebook that are friends. So, maybe Elin is friends with everybody. I'm not going to draw an edge from Elin to herself. As we said, we will not consider graphs that have self-loops. Maybe Alex and Kurt are friends, Kurt and Craig. So here we have a graph. It corresponds to a social network. It has 1, 2, 3, 4, 5 vertices, and 1, 2, 3, 4, 5, 6 edges. So 5 vertices, 6 edges. Now we've labeled each of the vertices with names. This is the Craig vertex, the Kurt vertex, the Parth vertex, the Alex vertex, the Elin vertex. How do we write down edges? Edges are written in this way. So there's an edge from Elin to Parth. So we call that the Elin, Parth edge. Craig and Kurt are friends, so we'll call that the Craig and Kurt edge. And so on and so forth. More generally, if you have a vertex U and you have a vertex V, and you'd like to write down an edge between U and V, you write it as U, comma, V. So left parentheses U, this is a U, so left parentheses U, comma, V, right parentheses. That's how we write edges. And another graph that you're probably familiar with is the web graph. So in this graph, we'll have a vertex for each web page. So, here's Google, and Yahoo, CNN.com, and ESPN.com, and utexas.edu. So imagine the web only had 5 websites, and we could draw a link from vertex CNN.com to vertex Yahoo if there's a link, a web link from CNN.com to Yahoo. And we could even indicate, we could make an edge directed. That means you put an arrow so the edge is going from one vertex to another to indicate that there's a link from CNN.com to Yahoo. So this would be a directed graph. So a directed graph is a graph where you have an orientation for each edge. It's either pointing to one of its 2 vertices. So for example, if there's a link from ESPN.com to utexas.edu, we'd write that edge, and this arrow indicates that the edge is going in this particular direction. And in a directed graph, you write down an edge. You start with where the edge is coming from, so CNN.com, and then where it's going to, Yahoo. This edge would be ESPN.com and utexas.edu. And in this graph, Google has no links. That's pretty weird. Google probably everything links to Google. And usually in this class, we'll be looking at undirected graphs. So we'll be drawing graphs, we'll be drawing vertices and edges that won't have these arrows, that won't have an orientation. But I just want you to be aware that there are graphs that do have orientations like this.